Hello everyone, welcome back to my video. I'm glad to see all of you today. In this video, I will use the trigonometric functions and the trigonometric equations. And Unit 1, you learn trigonometric values of a trigonometric angle. Now, let's get started. First one, I have part 1, trigonometric angle. In a plane, consider two rays, OU and OV, with the same initial point O. If the ray OM lie on the plane and rotate in a specific direction from the initial side OU to the terminal side OV, and the rotation determines the angle alpha, so we call is a trigonometric angle, and notation like this. And alpha is the measure of the trigonometric angle from the initial side OU to the initial point OV. And by convention, we determine the direction from OU to OV is the clockwise. It is clockwise is a positive, and counterclockwise is a positive, and clockwise is negative. So counterclockwise is considered for positive, and clockwise is considered negative. So with its initial side and the terminal side, we have many angles, trigonometric angle like this, or you can rotate like this, or you can go to the clockwise. We have the angle like this. So with each angle, we can write with the measure of the angle is the alpha plus k times 360 degrees, because each angle is subtracting or adding by 360 degrees. And in general, the measure of the trigonometric angle is right by the notation alpha degrees plus k times 360 degrees, with k is belong to the z with the integer, yes. And to measure the trigonometric angle, we use the degree, the unit degrees before, but now you have another unit to measure the angle, because you see, when you write, you go one or more than one circle, so degree is inconvenient because you use is very large, so you have another unit to measure the angles. It's called the radians. Now let's move to the part 2. Angle measurement with degrees and radians. With degree, part A, degrees, you learned it before, and in one circle have 360 degrees, right? Now let's add for a circle. to determine the radian. Oh my god. Let's try again. Okay, let me highlight it to see clearly the circle. Right. I have a circle, and in a full circle, in a revolution, we have 360 degrees. 360 degrees, right? And what is the radian? B. Radian. What is the radian? I have a circle with the radius r. The radius r with the initial sign, and I have a center angle. The center angle with the arc length. Here, the arc length equals the radius r. The radius r. So that means the measure of the center angle is called 1 radian. 1 radian is the measure of the center angle. The center angle with such that the length of arc of the circle is equal to the radius of the circle. So that means we have 1 radian. So now with the definition of the radian, we have the length of the theta like this. The theta equals the length of arc, with the ratio of the length of arc with the radius. So that means we have the formula of the arc length is equal to theta times the radius. It's called the length of arc, or the arc length. Now let's do some example. Example 1. I have example. A circle has radius r equals 2 centimeters. Find the length of the arcs subtended by the center angle of 2 pi over 3. Find the length of arc. To use the formula, the length of arc equals theta times the radius r. So we have the theta equals 2 pi over 3 times 2 equals 4 pi over 3 centimeters. That is the length of arc. Now, come back to the circle. We're curious about how many radian of a full circle. In the degree, we have 360 degrees in a full circle. So in the radian, how many radians in a full circle? To find how many radians in a full circle, you should remember the circumference, because in a full circle, theta equals the length of arc over the radius. So the length of a full circle is called the circumference. the circumference equal 2 pi r. So that means we have the length, the center angle in a full circle is 2 pi. 2 pi. So now let's find the relationship between radians and degrees. We have 2 pi equal 360 degrees, right? Now, in some application, we should convert between degrees and radian. So we should to remember 2 pi equal 360 degree. So divide to both sides by 2. We have pi equals 180 degrees to convert between radian and degrees. So we have 1 radian equals 180 degrees over pi. Divide both sides by pi. We have 1 radian equals 180 degrees over pi. And 1 degree equals, now let's divide both sides by 180 degrees. We have 1 degree equals pi over 180 radian. Okay, now let's do some example. Example 2. Convert a pi over 4 to degrees. To convert from the radians from the degree, we multiply with the 180 degree over pi. We have pi over 4 times 180 degree over pi. So we can cancel pi here and simplify 180 degrees with by 4 we have 40 degrees. So that means pi over 4 equals 45 degrees. Next, 90 degrees. 90 degrees, to convert from the degrees to the radians, you multiply with the pi over 180 degrees. Simplify, here we have pi over 2. So that means 90 degrees equal pi over 2. Now, let's move on to learn the unit circle. I have the part 2, the unit circle. Part 2, the unit circle. Now let's draw the unit circle. I think I'm to use another card to draw clearly circle here. Oh my god, something. Really a minute. Okay. Let me highlight again. Oh, now, what is the unit circle? I draw the coordinate plane with the x-axis and the y-axis. The unit circle is the circle centered by the origin with the radius 1. And we can see in the coordinate plane, the unit circle have the direction counterclockwise is considered positive and clockwise is considered negative. And unit circle intersect with 4 points: A prime, B prime. And you can find the coordinates of each point. A is 1, 0, B is A prime is -1, 0, B is 0, 1, and B prime is 0, -1. And the unit circle to divide the coordinate plane with four parts is called quadrants. And let's label the quadrants in the counterclockwise. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And in the unit circle, we learned how to determine the trigonometric value. Now I draw another unit circle. I have another unit circle. I have there the initial point A, and the counterclockwise is consider the positive direction. And remember, I have the right triangle to remind you the trigonometric values of the angle theta. In the right triangle, we call the side here is a hypotenuse. The side that is opposite with angle is opposite side. And the angle of the side here is adjacent. So remember the trigonometric angle, the sine of theta equals the opposites over the hypotenuse. Sine theta, cosine theta equal the adjacent over the hypotenuse. And I draw the right triangle in the unit circle. I have right triangle here. With the center angle theta. So I have the right triangle here. And with the trigonometric angle intersect, the terminal side intersect with the unit circle with the point M, and I call the coordinate of point M is xy. Use the right triangle. We have the side here is the side here is x, the side is y. So remember, sine theta equals the opposite over the hypotenuse. So we have the opposite is y over the hypotenuse is 1. Why? Because that is the unit circle with the radius 1. So that means we have sine theta equals y. And cosine theta equals the adjacent over the hypotenuse. The adjacent x over the hypotenuse 1. So we have x over 1. So that means we have cosine theta equals x. So we write the coordinates of the point M with the x is cosine theta and the y is sine theta. And we can use the coordinate of the point M to find the coordinates of all of the points on the unit circle, like B, A prime, and B prime. Because B is 0, 1, and that is the angle is 90 degrees. So you find the cosine 90 degrees and sine 90 degrees. So that means we have cosine 90 degrees equals 0 and sine 90 degrees equals 1. And you will find the coordinates of another point in the unit circle. And now, let's see. Take a look. Because the coordinates of the point M is cosine theta and sine theta. Cosine theta here and sine theta here. So now we call the x-axis is called the cosine axis. And the y-axis is called the sine axis. So we have the x. Now note. We have the x-axis is called the cosine axis. Then the y-axis is called the sine axis. And you can determine sine, the value of sine and cosine. Now, look, sine theta is go through from -1 to 1. That means we have the range of the sine theta is from -1 to 1. And do the same with the logic with cosine. Cosine go through the -1 to 1. That means you have the range of cosine is -1 to 1. And the tangent alpha equals they have the formulas equals sine theta over cosine theta. The cotangent theta equals cosine theta over sine theta. And now, in each quadrant, we can determine the sign of each trigonometric values. So let's see the unit circle here, and we have the sign of the trigonometric values. I draw the table like this. So you can draw it on your notebook. Okay, sine, cosine, tangent, and cotangent. Okay. I have quadrant, and the angle, the values, trigonometric values. Quadrant 1, 2, 3, and 4. We have the sine, cosine, tangent, and cotangent. Now let's see, in quadrant 1, the first quadrant, because we have the sine here, the sine is above the x-axis, so that means sine is positive. Cosine is in the right of the y-axis, so that means cosine is positive. So because tan equals the sine over cosine, so we have positive over positive is positive, and cosine is the same. With the do the same with the lower with the quadrant 2, we have sine is positive, cosine is negative. Because cosine is in the left of the y-axis, so that means tan is negative and cotangent is negative too. In the quadrant 3, we have sine negative because east is the bottom of the y-axis, and cosine is negative 2. So tan is negative over negative is positive. Cotangent is positive, also positive. In the quadrant 4, we have the sine is negative and cosine is positive. So that means we have tan and cotangent is negative. So we can to determine the sign of trigonometric values in the table. Or you can draw the unit circle and write the quadrant like this, and you can determine. Remember, the y-axis is the sine axis, and the x-axis is the cosine axis to determine the sign of its trigonometric values. Right now, I have a problem for everyone. Let's move on to part 3. Part 3, the relationship between the trigonometric value. And we have 4 identities. We have 4 identities. First, sine theta squared plus cosine theta squared equals 1. It's called the Pythagorean identity. Identity 2. 1 plus tangent theta squared equals 1 over cosine theta squared, with theta is not equal to pi over 2 plus kp, with k belongs to the integer. The third identity is 1 plus cotangent theta squared equals 1 over sine theta squared, with theta is not equal to k pi, which k belongs to the integer. And the last identity is tangent theta times cotangent theta is always 1, with theta is not equal to k pi over 2, with k belongs to integer. Now let's do some example. I have example 3. Given that sine theta equals 3 over 5, and that theta between 90 degrees to 180 degrees, find the exact values of cosine theta, tangent theta, and cotangent theta. Now, I take you some minutes to think about the problem 3. Now, to find the cosine theta, tangent theta and cotangent theta, with given that sine theta is equal to 3 over 5, we can to see all of the identities here, and we can see the first identity is the relationship between sine and cosine. Use the formula sine theta squared plus cosine theta squared equals 1. So cosine theta squared equals 1 minus sine theta squared and plug, because sine theta equals 3 over 5, so plug it in the equation. We have 3 over 5 squared, and simplify. We have now 1 minus 9 over 25 equals 16 over 25. Now, to find the cosine theta, we must to square root to both sides, and with the square root to both sides, we have the two values, that is opposite side, plus or minus 4 over 5. To determine the sine of the cosine, we have, because theta is between 90 degrees to 180 degrees, so we have the theta is in the second quadrant, so sine is positive and cosine is negative. So we have cosine theta equals negative 4 over 5, because theta is between in the second quadrant. Now we find tangent and cotangent. How do we find tangent and cotangent? To find the tangent, we can use the formula, because the relationship between tangent and sine and cosine, tangent equals sine over cosine. We have tangent theta equals sine theta over cosine theta. So, look the values on the equation. We have 3 over 5 over negative 4 over 5, and simplify we have negative 3 over 4. And to find the cotangent, you use the fourth identity, because tan and cotangent is the reciprocal, so we have cotangent theta equal 1 over tangent theta. So we have negative 4 over 3. Now, and the last part today, we will learn the relationship between the specified trigonometric values. 4. Finding reference angles. Finding reference angles. Finding reference angles, we have some angles are relationship between, that is called theta or alpha and pi minus theta. Two angles are called supplementary angles, because two angles plus added is 180 degree or pi. So the relationship between the trigonometric values is both angle is sine pi minus alpha equals sine alpha. But the another trigonometric values is opposite side. Cosine of pi minus alpha equals negative cosine alpha. Tangent of pi minus alpha equals negative tangent alpha, and do the same with the cotangent. Okay. Now we have another specified angles. It's called complementary angles. It's complementary angles alpha and pi over 2 minus alpha is called complementary angles, because when we add it up is exactly pi over 2. And with the relationship between the reference angle is sine of pi over 2 minus alpha equal cosine alpha. Cosine of pi over 2 minus alpha equals sine alpha. Tangent of pi over 2 minus alpha equals cotangent alpha. And cotangent pi over 2 minus alpha equals tangent alpha. And with the alpha and the opposite side of alpha is called the vertical angles. Vertical angles. With vertical angle, we always have cosine of negative alpha equals cosine alpha. Sine of negative alpha equals negative sine alpha. And tangent of negative alpha equals negative of tangent alpha. And cotangent of negative alpha equals negative cotangent alpha. And the last one we have two angles differ by pi. So with the two angles we have tangent of pi plus alpha equals tangent of alpha, and cotangent of alpha plus alpha equals cotangent of alpha. And sine of pi plus alpha equals negative sine alpha, and cosine alpha plus pi equals negative cosine alpha. Now let's do example. Example 4. Calculate cosine. Don't use the calculator. Calculate cosine of negative 11 pi over 4. Now, take a look with the angle. We have the negative 11 pi over 4. So you can use the vertical angle first. We have cosine of negative 11 pi over 4 equal cosine of 11 pi over 4. So, after that you can see 11 pi over 4 is greater than 2 pi. So we can write plus 2 pi here. You can subtract 11 pi over 4 by 2 pi. 2 pi. First we have 2 pi, and we have 11 pi over 4 minus 8 pi over 4, and is equal to 3 pi over 4, right? And we rewrite cosine of 11 pi over 4 equal cosine of 3 pi over 4 plus 2 pi. Because the cosine is periodic, so cosine of 3 pi over 4 plus 2 pi is equal to cosine of 3 pi over 4. And we can rewrite 3 pi over 4 is equal to pi minus pi over 4, right? So you can use the supplementary angles. So that means we have cosine of pi minus alpha is equal to negative alpha. So that means we have negative cosine pi over 4. And cosine pi over 4 is equal to the square root of 2 over 2. And that is. And that's all for today. I know it's too many knowledge in this video. I hope you can understand. But if I have a mistake, please give me some feedback in the comments. Thank you for watching. See you in the next video. Goodbye.